When looking at polar coordinates, sometimes we need to be able to translate between what we have in polar and what we have in rectangular. So let's figure out what is something that they have in common. So rectangular coordinates are in the form x comma y, and polar coordinates are in the form r comma theta. So we know that the cosine of theta is x over r. So the cosine of theta is x over r. And we know that the sine of theta is y over r. Y over r. Now, if we want to try and convert from x comma y to r and theta, well, we need to isolate x and y so that we can express our rectangular coordinates in terms of something with polar. So for this, we would just multiply both sides by r, and we would actually do the same over here. And we get that r times the cosine of theta is equal to the value of x. And then here we would get that r times the sine of theta is equal to the value of y. So whatever your distance is from the pole times the sine of your given angle, that's going to be equal to your y coordinate in rectangular form. And then whatever the value of r is times the cosine of your given angle, that's going to be the x value of your given coordinate. So if we use this fact, or if we recognize this fact, then that means that polar coordinates r comma theta can be rewritten as rectangular coordinates if we use this to convert it, r comma theta and r cosine theta comma r sine theta. Well, that will give you the x values, and this will give you the y values. So let's use this to try and convert between rectangular and polar coordinates. So for this example, we're given the polar coordinates 3 comma pi over 2, and we want to find the rectangular coordinates. So again, remember, we want to take this and convert it into x comma y. We know that x is equal to r times the cosine of theta, and that y is equal to r times the sine of theta. So r and theta, to find my x coordinate, it's going to be 3 times the cosine of pi over 2. So this is 90 degrees. At pi over 2, or 90 degrees, the x coordinate, which is cosine, is 0. So this is 3 times 0, which is 0. So our x coordinate is 0 here. For the y, it's y equals 3 times the sine of pi over 2. The y coordinate at pi over 2 is 1. So this is 3 times 1, which is 3. So our ordered pair in polar, 3 comma pi over 2, right? This is r and theta, r comma theta. When converting it into rectangular coordinates, it's going to be 0 comma 3. 0, 3. So this is x comma y, rectangular coordinates. So that's going from polar to rectangular. Let's take a look at another one. We have the points -4 and -pi over 4, and again we want to find the rectangular coordinates for this. So this is r and this is theta. So again, we're converting it into x and y. So x is r cosine theta, y is r sine theta, and let's go through and plug these in. So x equals -4 times the cosine of -pi over 4. -pi over 4 has a cosine of rad 2 over 2. So this is -4 times the positive square root of 2 over 2, which is going to be, this can reduce to be -2 rad 2. For the y, it's y, and that's x, right? This is the x. For y, it's y equals -4 times the sine of -pi over 4. So at -pi over 4, the y coordinate is -rad 2 over 2. So it's 4 comma negative square root of 2 over 2. Negative times the negative is going to be positive. These reduce here, so we get positive 2 rad 2. So converting into rectangular coordinates, -4, -pi/4 turns out to be -2 rad 2, +2 rad 2. So that would be our rectangular coordinates.